like this, 8 minus negative 3/8k equals negative 4. What we need to do is we need to isolate the variable. We need to get our k by itself. Now, to do that, we need to apply what we call our inverse operations. We need to undo what's happening to the variable. So I need to look at this and I need to determine what's happening to my variable. Well, I have it, my variable is being multiplied by a fraction, a negative 3/8. And then what is this 8 doing to it? And this is what confuses a lot of students. Well, some of you might say, well, the 8, you're subtracting it. Well, no, this 8 is a positive 8, right? That's a positive 8. So the 8 is actually being added to the k because this is a negative 3/8 that's being multiplied by k. So sometimes make this a little easier to understand. What I'll do is I will rewrite this. And I'll just switch around the 8 and the negative 3/8 k. Now, is this still the exact same equation? I mean, the same value of the equation? Yeah, all I did was I rewrote these, but my negative 3/8 is still negative, or my 3/8 is still negative, and my 8 is still positive. Now it might be a little bit easier for you guys to see what is happening to my variable. It's being added by 8, and it's being multiplied by negative 3/8. So the first thing I need to do is undo addition and subtraction. So you notice that my variable is being added by 8, so I'm going to subtract an 8 on both sides, which we call the subtraction property of equality. Then 8 plus negative 8 is 0, and 0 plus anything is just going to be our remaining term. So then I'll have negative 3/8 k equals negative 4 minus 8, which is a negative 12. So now I have my k is being multiplied by a fraction. And to undo multiplying by a fraction, we can multiply by the reciprocal. We could also divide it, but if you guys remember dividing fractions, one of the simple ways to divide fractions is to multiply by the reciprocal, right? So what I'll do is I'll just multiply by the reciprocal, and what I'm also going to do is I'm going to make that reciprocal negative. All right? And the reason why I want to make this negative is because if I just multiply by 8/3, I'm going to have a negative k. And I don't want to solve for negative k, I want to solve for k. So I'm going to multiply by a negative fraction on both sides. So therefore, any number multiplied by its reciprocal, that multiplies the 1. 1 times k is just k. Now we need to do negative 12 times negative 8 over 3. Well, remember, multiplying a whole number times a fraction. All right, and what I can do is I can divide these out. Right? I can just divide across the multiplication. So therefore I have negative 4 times negative 8, which is a positive 32. So therefore k equals 32. Okay?
Plus 6 on both sides. And then last, you multiply by 14 on both sides. So this one is gone. B equals 14.
So to isolate the variable x on the left side, we have to undo this multiplication and undo this subtraction. And we always want to undo the addition or subtraction first before we undo any multiplication or division. And the opposite of minus 2 is plus 2, so we'll add 2 to both sides of the equation. So we have 2/3 x minus 2 plus 2, that would be 0. That's why we did that, equals 4 plus 2 is equal to 6. Now remember, our goal is to have x equals some number. And since these are connected by multiplication, we might be thinking we should divide by 2/3. Remember, dividing by 2/3 is the same as multiplying by the reciprocal. So instead of dividing by 2/3, we're going to multiply both sides by the reciprocal of 3/2. Let's go ahead and put this 6 over 1. When multiplying reciprocals, the product is always 1. Notice how these 3 simplify out and these 2 simplify out, leaving us with 1x or just x. And then on the right side, we have 3/2 times 6. But notice that 6 and 2 share a common factor of 2. There's 1, 2, and 2, and 3 2s and 6. So we're left with 3 times 3, which is 9, all over 1. So x equals 9.